In this lesson, we are first learning conditional statement like if, else, or else if. After that, I'm going to explain the array, how to define an array, how to fill it up, how to read value of array. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. In this lesson, we are going to learn about conditional statements. What is conditional statement? An action is taken based on a condition. For example, if price is high, do not buy. This color, the bluish color that I try to show, is condition, and this color shows the action. Let's see, if temperature goes below 18 degrees Celsius, then turn the heater on. Or if age is greater or equal to 18, can drive without instructor. Or if the size is between 8 and 9, it will fit. So these are all conditions, and these are the actions that we take. Another one, if the speed is between 90 km per hour, driving too slow. Else, now we have else, we introduce something else. Else, if the speed is between 90 km per hour and 110 km per hour, driving okay. In this case, we have and we have two conditions with else. So this was the main if, and this is else. Else, take photo of the driver and email the fine slip. So this is, let's say, the traffic camera. If the speed is 90 km per hour, it's too slow. Else, if it's not 90, it's between 90 and 110, driving okay, nothing happens. Else, take the photo and send it. So what it means is, it's not between 80, 90 and 110, it's not below 90, it means it's above. So send a fine ticket. And another example is, if the mark is below 90 to 100, the grade is A. So this would have been something that used in school, for example. Else, if between 80 and 90, that's grade B, and between 70 and 79 is C, and 60 to 69 is D, and else mean otherwise. If it doesn't fit between these, then the person is failed, or F. So how we can define a conditional statement? So we type F, open and closing parenthesis, and then this curly braces are here. So this is condition. We put the condition if this condition is true. It's very important. The whole point is about true. If this is true, then take action. So the action is between this curly brace and this curly. So whatever you write in here, it will be executed if this condition is true. We can also move this curly parenthesis down. The condition is there, action is here, and all the action that you have must be between this opening and closing. And here, this code will be executed. It doesn't matter if it is 1 line or 100 lines of code. Now, here is the actual example. We say if the speed is below 90 km per hour, driving too slow. So here, speed is a variable and this is a number, so we use greater than and less than sign. Here it says speed is less than 90. If that's the case, let's say the action is to just print this text, driving too slow. If the speed is between 90 and 100 kilometers, now we have and, driving okay. Now let's see how we can implement and. If speed is greater than or equal, when we want to say greater than or equal, it means greater than 90. So 90 is also included here, and then and, this and, speed is smaller than or equal 110. In this condition, we are setting that the speed must be between 90 and 100. So we use and here this is how we implement the condition, and then the action that we do is nothing except just print this text. This is just an example, but you can do anything else that you want with your code. Else, take the photo of the driver and email the fine slip here. Else, then we write else and then open and closing. Else doesn't have any action. It just says else mean otherwise. We just print this text on the screen. Here we are implementing the mark. If the mark is greater or equal than 90 or smaller than 100, we put ampersand here. So in this case, this means between 100 and 90, and here it's between 89 and 90. Between 70 and 79, between 60 and 69 will be D. So these are the actions, grade equal, grade equal. Otherwise, else mean grade is equal F. Here is the example of the grade. We have an integer variable mark. The value is at the moment 75. A student has a 75% mark. We want to see what is the grade, and we are defining a character called grade. And inside the setup, the whole code is running inside the setup. In the loop we don't have anything, so this just runs once. Here we say if mark is greater or equal than 90, and these two ampersand mean and. If this is true and the mark is smaller than 100, so which means it should be bigger than 90 and smaller than 100, then this letter A, which is a character, will be assigned to the variable grade. How we know it is character? Because we have a single quote here. If this was a string, then we put double quote like this, double quotation. Because it's a character, we put single quotation. Remember, the type is determined here. And then we say else and then a space if mark is greater than 80 and 89. So this means between 80 and 89. Still 75 doesn't fit here, so it will not be true. And the code comes to this line. It checks if it is between 70 and 79, which is true. Then C will be assigned to grade. This will not happen because our number doesn't fit. When C is assigned to grade, this will not be executed. None of this. The code will exit from here to here, and after this exit, and then here the execution comes at this line. We define a serial monitor with 9600 baud to display the code, and then we print this text grade is inside this double quotation, and then the grade, whatever it is, we print it here using serial print ln. So these two lines will print it for us. Grade is C. If you need to test any other value between 0 to 100, just test it. Let's say 89, and you will see it here. We know between 80 and 89 it should be B, and it printed B. 56, grade is F. Pay attention here. For simplicity, we did not use this text every time inside this condition. We could print it here, whichever was true, it could just print it. But this would have been used multiple times in every condition. Now what we did was we just assigned the letter to this variable and then use the variable here, so we can just print it once, not 4 or 5 times. And we assign 10 to X. This is initialization of the serial monitor with 9600 baud. This line we define a variable K of type integer and we assign 5 to this K. And then we define variable X of type integer, and here we check if X is greater than K, then we print serial print ln, we print this text, X is greater than K. If you look here, X is 10, K is 5, so this is true, and it will print this statement, X is greater than K. If this was not true, this will be executed and it will be printed on the screen. Now let's change this to 12 and update it. Now X is not greater than K, so this will be printed. Else. So this text is now printed. Whatever you type here, it will be printed. So the whole point is that this is executed. Whatever you put between this and this will be executed at this point. Now let's see how we can implement the OR condition. For OR, for example, if K is equal 10 or B is equal 12, then the action is to say that it belongs to group alpha. Here we say if K is equal, we put 2 equal signs, because 1 equal sign means assignment, assign 10 to K if it was like this. But because we have 2 equal signs, it means compare. Compare K. K is a variable of type integer and it has some number, and we compare it with 10 if it is equal, or 2 pipe. These are the two, the one pipe that is on the keyboard. In US English, it's just above enter on the right side. So you put 2 pipe and then B equal 12. If B is equal 12, then alpha. And here if K is greater than 10 or G is equal, you see this is greater and G is equal 15, we implement it like this: K is greater than 10 or G is equal 15, then group is beta, otherwise or else, then not valid. Group is not valid. So we just assign a text to this variable called group. That's our action. Here is our action and here is our action. And this is now AND OR, so we can implement both of those. In this case, you see this is our AND F. If K is equal 10 or B is equal 12, and we put one more condition: if G is smaller than 9, then group is alpha. You see the OR, pay attention, and in here. And again we have also OR here. So the whole point was to understand that we can put side OR and then another AND. So the whole point was to have one condition inside one parenthesis with OR and ampersand with something else. Now this is nested if, so we can say if age is greater or equal than 20. So this if starts from here, and then we have another if condition. This is called nested if inside if. So we say if total is smaller than 10.56, and so these two means and total is greater than 8.6. So it's between 8.6 to 10.5. Then the action is to print this text: eligible for discount, otherwise regular price. And if age is not greater than 20, then we say not valid. So this discount is perhaps for people of age 20 or over. We can do if nested, we change it and we make it simpler like this. If you can understand it easily, it will be the same thing. We say if age is greater and the total is smaller than 10.5 and the total is greater than 8.6. So everything is in one opening and closing parenthesis, and this is the action, else this is the action, which is regular price. Array in Arduino. So what is an array? For example, if you define a variable called age with the type integer and the value 25, this is one variable with one value. If you need multiple of this age, you might do it something like age 1, 25, and then you have another age 2, 21, age 3, 23, and age 4, 30. So you have to do it differently with 1, 2, and 3, and 4 in order to accommodate and define each separately. Is there any better way to do it? Can we do, for example, to have one variable to hold multiple values? For example, for all these values, age 1, 2, 3, and 4, and these are the values, can we have a solution? Yes, so this is how we do it. We define one variable age and we put this square bracket in front of it, and that refers to an array. Array means multiple value in the same variable. Internally, it defines a stack of different memory location to put these values. But for us, this square bracket refers to an array, which means age has multiple values, and these are the values, and we put a curly parenthesis, put the value, comma, separate each values. So this is the type. You can have array of character, array of boolean, array of string, all data type that are available for regular variable will be available for array as well. And this is the array name, and these are the values for the array. As you can see, 25 was for the first one, we put it, and then 21, and then 23, and 30. And the position of each is referring to a value, we call it index. So the index value for the 25 is 0, for this one is 1, 2, and 3. So array index starts with 0 and it goes up. Now, how can we read array values? I'm just bringing the array here with our value, and let's see. If you want to get this index 1, if you want to get the 21, you just type age, and inside the square parenthesis you just put 1. If you use serial print, it will print 21, because age with the index inside it is referring to the 21. And the same way, if we have age 0, it will print 25, and age 2, if we have, we get 23, and if we have age 3, we get 30. Let's have a look at it in Arduino. This is the code for Arduino for the array age with the values 25, 21, 23, and 30. And inside the setup, I have defined the serial monitor with 9600 baud, and then I've just used serial print ln with the age 0, with age 1, 0, 2, and 3. And in the loop there is nothing, so it will run one time and will be executed. Let me upload the code. And if we open the serial monitor, it will just execute one time, and we will see the values. 21, 25, 23, and 30. Index 1 is 21, and then 0 is 25, and then 2 is 23, and then 3 is 30. Let's now see how we can update the values for array. So this is our array, just for reference here. And let's say you want to update 21 with 42. So this is how you do it. You type the age and then the index. This 1 refers to this position, and then equal, and then put the new value. In this case, we put 42. So what happens is that 42 goes into index 1 of the age. So this will be updated like this. So the array becomes now with the new value of 42. and let's say you want to have 22 into index 3. So index 3 means in here. So this value now have been updated. And if you do 18 into index 0, so we will have this 25 have been replaced now by 18. And if we do 20 into 2, 0, 1, 2, and you will see that 23 have been updated into 20. I've updated the array now. I put this line so we know when this is printed, this will be separated. I've updated all the index with these new values, and I've copied and pasted this here, with the exception of updating this comment 1023, the index 1023. Uploaded it to the board, and now let's see. As you can see, initial value was 21, 25, 23, 30, and they have been updated. This second portion after this line have been printed in here. So the array values have been changed. Now let's learn about defining an empty array. Sometimes you need to define an array, but you don't have the values at that moment. Later on, for example, you can read a voltage, you can read a temperature, you can read pressure, speed, or other values, let's say for 4 different items, and you want to create an array and later on fill it up or maybe update it. For that reason, if you don't have the value, you can initialize an array, an empty array without values. This way you define it. Let's say you don't have the age values, but here there is one thing that you must put 4 here. This 4 means this array will be defined inside Arduino, inside the microcontroller, in the memory, and will have 4 empty spaces. If you don't put this 4, you will get error. In previous example, when I did this, it was empty, but I have the values. Now, because I don't have the values, I must have this here. Let's see how can we fill this with these values 30, 27, 22, 31, and if you see in terms of index, that is 0, 1, 2, and 3. So exactly like before, like updating, update and filling up is the same. This means that 30 will go into index 0 of age, and this means 27 goes in 1 because this is empty. Now we are filling it up, and 22 into 2 this way, and 31 into 3. There is another data type called float in Arduino, and the float can take 4 bytes. So 4 bytes times 8 bit is 32 bits. That's the total length of the value that is stored. We can get as large as 3.402835 times 10 to the power 38, and also the same value with a negative, because it's a signed value. You can put negative and positive values in the float. And according to Arduino website, the precision can be only 6 to 7 decimal place. If you want up to 15 decimal place precision, then we have to change the float to double. For further information, please visit arduino.cc reference page and read about the data type float. Now let's define an empty array. How can we define an empty array? Now let's define an array of the type float. Before this was integer, now we are using float, and this is the name. Let's say call it marks, and it has 4 values. This is exactly the same as before, which was integer and a. When you put 4 here, this array can take only 4 values. Let's say you want to fill this array with these float type data: 49.5, 45.7, 36.2, and 40.7. And in terms of index, this is the position. We want to have this in 0, this in 1, 2, and 3. So to store this, we type marks 0, and the same as before, we put the value, and then for 1, 2, and 3. Now I have defined this array marks with a type float with 4 elements, and I've assign these values, store them in index 0. This has been stored in index 1, 2 and 3, and this is now printing it. And then serial monitor is printing them the same exactly as before. This is not in order 1, 0, 2 and 3. Let me open the serial monitor, and as you can see, these lines are printing the values for us with a float. Let's see how we can read all the values of array, not just single one value, and continuously read multiple value. For that reason, we have to use something called loop. Now, loop is a function in programming languages that does specific task or tasks and exits at a certain condition. And this also has an index, and based on an index, you can pull different value. For example, now in this one, we have for loop, and it has opening parenthesis, closing parenthesis, and then we have one semicolon, another semicolon, which is one portion, another portion, and another portion. It has 3 sections inside this opening and closing parenthesis, and then the curly parenthesis is the area where the command or whatever you want to be executed. To explain it, now when the program starts running, when the program reaches to the for loop, initially it defines integer I equals 0. That's the first thing that happens. So we have I equals 0. After that, it goes to the second portion, which is compare. This is initializing and then comparing. Now it checks, is I smaller than 4? If this is true, then it comes and it does the action. So this is serial print ln I, because I is 0, so this is the value that is printed on screen. After this, it goes to this point, and this I plus plus means increment. Increment means add one more on the current value. Because I is 0, now I will become 1. And after this, we come back here and then compare. Now, is I, which is 1, smaller than 4? If it is true, it will proceed. If it is false, it will exit. Now, I1 is smaller than 4, it will proceed here and it will print 1. Pay attention here that we don't go back there. We just go like this in this area. So I is 1. This has been printed. Now we go in here, increment, and I become 2. After this, we go in here, and 2 is 2 smaller than 4. True. 2 is smaller than 4. Then come here and print. We will see 2 on the screen. Now we go again here, and then increment I. Now I is 3. Check. Is 3 smaller than 4? True. Come here and print. 3 is printed. Now we go again, increment. Now I is 4. And here we compare. So I is 4. Is 4 smaller than 4? No. So this is false, and the loop exits. And whatever code after this is on your Arduino screen, that will be executed. So this is very important to know that when the code reaches to the for loop, it will not go to the next until all the iteration or the execution code that has been executed. If you put here 1 million, it will do 1 million times before exiting, or whatever other tasks that you put here. For simplicity, I just put here I. Now I've printed that code here inside the setup because it will run one time, and this loop goes from 0 up to smaller than 4, and it will print I. Let me open the serial monitor, and it prints 0, 1, 2, 3 as I explained. Now let's see how we can print all the values of an array using loop. For example, we have an array of age with a type integer, and these are the values 30, 27, 22, 31, and the index is from 0 to 3. So it has 4 elements. We can use the same type of array as before, except instead of I we put age, and inside this square parenthesis we put I. When we put I, this is as if we put 0 and then 1, 2, 3. So it would go 4 times, and when I is 0 it prints 30. Why it says we print this is 30 and we put this 30 inside the serial print ln, so this prints it. Otherwise we can use it for other purpose, and you can do some calculation or whatever. So imagine that when I is 0 this is 30, and then when I is 1 it will print 27, and then I is 2 it prints 22. When I is 3 is smaller than 4, it prints 31. After that it goes back, makes it 4 is not smaller than 4, and exit. Here is implementation of that. This is my array with 4 elements, and this is a for loop. Initialize I with 0, and it goes from I from 0 to smaller than 4, which is 3, and then age I. This will print. Let me open serial monitor, and as you can see, that was the previous array was just printing 0, 1, 2, 3, and this is after this line it prints this section. This loop is responsible for printing these 4 values. Let's see how we can fill up an array at once. Let's say you're creating an array of type integer, the name is price, and it has 10 elements, and you want to fill it up with some values. And here, like before, we go with a for loop. Initialize I with 0, I smaller than 10, so this I goes between 0 to 9 increments. And here we do a little extra work. Price I, so that is as before, equal, but we don't just put I or anything. What we say is I plus 3. So when this is 0, it will be 3 will be filled up. When I is 1, 1 plus 3, 4 will be there. So in terms of index 1 would be 4. 4 will be 7, 5 will be 8, 6 will be 9, 7 will be 10, and 8 will be 11, and then 9 will be 12. That will be 12. When it comes here, it becomes 10. 10 is not smaller than 10, it will exit. Now, the array will look something like this. We will have all these values filled up, and in terms of index, this is 0, 1, 2, 3, up to 9. We have 10 elements. We can read it using a for loop. Again, I equals 0 and I is smaller than 10, and then we call price, and this will print the value for us on the screen. Let's have a look at it. So here is the code, and we have the array with all these values, and then the loop goes from 0 to 9. Always when you see 10 I smaller than 10 without equal sign, that goes to 9, and then price I goes here and print, and the loop is empty. Uploading the code. Here the code is loaded, and as you can see, all the values using this for loop being printed from 3 to 12, all of them. This is the code that we have defined 4 LEDs, LED 1, LED 2, 3, and 4, and these are the pins that I have connected as I shown you on the diagram. And inside the setup, we first set the pins as an output, LED 1, LED 2, 3, and 4, all of them as an output, and then we set the serial monitor 9600 baud, and then we say digital write LED 1, 2, 3, and 4, all of them as low, so the LED is turned off initially. And then inside the loop, we just this is one portion of for one LED, then this is for another LED, and so forth. For each LED I have 4 lines. Digital write, LED 1, high, so we turn on the LED. LED 1, LED 2, LED 3 are variables, that means 2, 3, 4 and 5. So this means 2, and then we wait for 1 second, 1000 milliseconds, so it can be seen for 1 second, and then digital write LED 1 low, so we turn off the LED and wait for 1 second. After that, for LED 2 the same thing, on and then off, LED 3 and LED 4, and then this continues like that. Here is the wiring diagram. Breadboard, I have 4 LEDs and then 4 resistors of each 1 kilo ohm, and this is the positive or anode of an LED on this side for all of them, and this is the cathode. On the cathode I put the resistors. And here is the schematic diagram in case if you want to know. The pins have been shown. So from pin 2 it's connected to the anode and it goes to cathode through this resistor. All of these resistors are connected to this line, which is connected to the ground. So from pin 2 it's connected to the anode and it goes to cathode through this resistor. All of these resistors are connected to this line, which is connected to the ground. LED 1 is connected to pin 2, 3 is connected to the LED 2, and then 4 is connected to the LED 3, and then 5 is connected to LED 4. Here is the actual wiring that I have done. I've put resistor, I've put all these LEDs, and from one pin I have resistor to the one common, and this is connected to the ground. The shorter pin is connected to the resistor. For all of this, the shorter pin is connected to the resistor. From my Arduino, from pin 2 to 5, I've taken these 4 wires, connected. That is pin 2, this wire. Wires have been connected from this side, pink, yellow, green, blue, pink, yellow, green, blue. And the ground is connected to this ground of Arduino. And the code is being loaded, on and off, and then the next one on and off, third one, and then the fourth one, and it comes back, on and off, and so forth. Now I've changed the code, so this one is turned on and stays until the fourth, and then all of them turn off, on, and so. Let me explain it now. I moved this portion that was initially turning off the LEDs. I brought them here inside the loop. So initially we turn off all the LEDs, you see, now it's turned off, and wait for 1 second. Then we turn on the LED 1, as you can see, and then wait, and then we turn on the LED 2 and wait, and then we turn on the LED 3 and wait. Because the LEDs have been turned off before, all of them are off and waiting, and LED 4 turned on and wait. When everything is turned on, the loop comes here back and turns everything off, waits for a second, and then continues like that. Here now I'm using the same code that I've just shown you. I'm using array, and see how simple this becomes. I've defined 4 variables for 4 pins, 2, 3, 4 and 5, and each will have one variable. Here I've just have one variable called LED as an array, and it holds all the values. And then we go inside the setup, and using these 4 lines to define pins as an output. This might not look that simple, but if you have tons of other tasks, this is very simple. Actually, this, we could say that this is done with 1 line. inside the for loop. So the for loop goes from I equal 0 to 3 less than 4, and we set I, so when I is 0 it picks up this as if we type here 2, and when I is 1 as if we type here 3, exactly the same as this one. So we put those values here and set the pin as an output. After that we initialize the serial monitor, same thing here, and here we have to turn off all the LEDs using for line, and here with a for loop we just do one line, and from 0 to 3 we set them low. After that we wait for a second, and here this is for a second, and this is the code that is for 4 LEDs. We do 2 lines for each LED. First we use digital write as high, and we set the pin high to turn on the LED, and when I is equal 0 we set the pin as high and we wait for a second. Then I is equal 1, we do the same thing, 2 and then 3, and then the code exits, come here. When it reaches here it goes back to the beginning of the loop, turns off all the LEDs, wait for a second, and continues. This is the exact code as before, but it's running using the for loop. This was the introduction to array and for loop, and also I showed you how to control 4 LEDs using for loop and array.